I can still feel the hum of those final thruster burns as if it were yesterday. I'm leaning forward in my chair, eyes locked on the telemetry feed, heart pounding in my chest. Because in that moment, I wasn't just an engineer or a mission controller. I was the pilot of humanity's first real attempt to steer an asteroid away from Earth. When DART separated from its launch vehicle on that July morning in 2021, a collective gasp echoed through mission control. We'd trained for years, ran simulations by the thousands, yet nothing could fully prepare us for watching a car-sized spacecraft slip the bonds of Earth's gravity and vanish into the void. I remember the knot in my stomach as we lost that first visual, knowing we had 6.8 million miles to go and zero margin for error. In those early days, guiding DART felt like plotting a course on a map drawn in sand. We dialed in our intended trajectory, accounting for solar gravity, solar radiation pressure, and tiny perturbations from passing planets. Each week, we'd receive updated tracking data and refine our path. I'd pore over the numbers late into the night, fueling myself on coffee and the belief that we were doing something historic. As DART drifted past the orbit of Mars, the pace of operations picked up. My team and I switched from broad trajectory planning to fine navigation tweaks. That's when SmartNav came online, our onboard autopilot detective. I watched fascinated as Draco camera frames streamed back, a dark point against the star field that grew, inched closer, revealed surface features. I felt a thrill every time SmartNav confirmed a mid-course correction had fired exactly as predicted. 6 months slipped by in a blur of data downloads and celebratory high-fives whenever a maneuver succeeded. And then, impossibly soon, we were 66 million miles from home, staring at our distant quarry, Dimorphos, a 160-meter moonlet dancing around its larger companion, Didymos. In my mind, I saw it as a ticking clock. Every second brought impact closer. Every pixel on my screen, a countdown marker. 2 weeks before impact, we held go-no-go reviews. I sat in that control room with sweaty palms, listening to experts weigh in on navigation uncertainty, thruster health, and software stability. When the final go message crackled over the comm channel, relief washed over me. Fleeting, because I knew the hard part was yet to come. We were about to hand off DART to its own systems. No more commands from Earth, no more second chances. Then, the final hours arrived. Communication latency stretched to 16 minutes each way. By the time I saw DART's images, it had already flown past. We had to trust SmartNav completely. My jaw clenched as I watched the last few frames. Crater shadows lengthening, surface textures sharpening, the telltale glow of sunlight grazing the rim. In those final 10 seconds, I felt every beat of my heart echoing in my ears. And then, impact. A heartbeat of silence on the comm loop, followed by the faintest blip in the data stream. A sudden jolt. A black pixel where once the moonlet had been. We erupted in cheers, tears, laughter. I grabbed a colleague's shoulder and screamed, "We did it! We actually did it!" But even as we celebrated, I knew the true test lay ahead. Would Dimorphos' orbit really change? Over the following days, telescopes around the globe trained on Didymos. I watched live feeds from radio observatories in Spain, optical telescopes in Chile, radar arrays in California. Every observation felt like decoding a cosmic puzzle. Was that half-hour shift in orbital period real? When the numbers finally came in, 32 minutes, I felt a strange mix of triumph and awe. We had moved a world. But with triumph came reflection. We'd proven kinetic impact works, yes, but on one small, porous asteroid. What about the gargantuan rocks out there? The million-ton behemoths? That question propelled me into planning the next phase of planetary defense. Because DART's success isn't a final solution, it's the opening act. Enter Hera, ESA's follow-up mission. I've attended meetings where we pore over Hera's design. High-resolution cameras to map DART's crater, spectrometers to analyze ejecta composition, gravimeters to measure Dimorphos' mass. I often imagine myself aboard Hera, circling Didymos decades from now, unraveling the forensic details of that fateful crash. Every data point will refine our models and shape future deflection strategies. Meanwhile, back on Earth, work continues apace. I've been part of design reviews for Surveyor, NASA's infrared telescope dedicated to finding dark, hard-to-see asteroids. We're talking about detecting 90% of objects larger than 140 meters, football fields, and bigger, years before they threaten us. That lead time means smaller nudges with lower energy, turning what would have been a last-second panic into a routine mission. We're also exploring gravity tractors, spacecraft that fly in formation alongside an asteroid, their weak gravitational pull gradually tugging it off course. In theory, you could steer a house-sized rock using nothing but gravity and time. I've run the math late into the night, balancing tractor mass, hover distance, and weeks, maybe months, of continuous thrust. It's elegantly simple, but demands unwavering precision. Then there are ideas for multi-impactor swarms, dozens of small probes raining down on an asteroid's surface, each delivering a micro-shove that collectively shifts its path. I get goosebumps envisioning the choreography, spacecraft deployments from multiple rockets, autonomous targeting, simultaneous impacts, a cosmic ballet with Earth safety at its center. All of this coordination requires global collaboration. I've been in UN working groups where representatives from dozens of nations debate data-sharing protocols and crisis response plans. We're building a planetary defense network that spans continents. Radar stations in Australia, optical observatories in South Africa, command centers in Japan, Europe, and the Americas. No single country can or should go it alone. When I mention these meetings, people often ask, is the threat real? I show them the statistics. Tens of thousands of known near-Earth objects, with dozens discovered each week. I remind them of Chelyabinsk in 2013, a 20-meter rock that exploded over Russia, injuring over 1,000 people and damaging buildings. That event was a warning, a dress rehearsal for something far worse. And yes, I've lost sleep imagining a civilization-ending impact. But I've also found hope in the extraordinary talent and dedication of our scientific community. I've met graduate students decoding asteroid compositions, engineers crafting radiation-hardened electronics, mission planners choreographing interplanetary trajectories. We're all united by a singular mission: protect our home. Sometimes, when the stress peaks, I step outside and look up at the night sky. I pick out the Milky Way's faint band, the occasional shooting star, and I whisper, "We've got your back, little rocks." It's a silly habit, I admit, but it reminds me why I do this work. Because every piece of data, every simulation, every long meeting brings us closer to ensuring Earth remains safe for generations to come. I could go on for hours about the technical minutiae, the nav filter matrices, the thruster calibration sequences, the telemetry protocols. But that's not what this story is about. It's about possibility. It's about the realization that in the face of cosmic forces, we have the creativity and the will to respond. We are not passive victims of fate. We are active stewards of our planet's destiny. So here's my challenge to you. If you believe in the power of human ingenuity, if you're as excited as I am about steering asteroids instead of robbing banks, or curing diseases, or building cities on Mars, smash that like button now. Better yet, subscribe and ring the bell, because on Lost Pages of Science, we dive deeper into these frontiers every week. In the coming months, we'll follow Hera's journey, track Surveyor's discoveries, and explore prototype missions that could one day deflect a real threat. We'll speak with the scientists who crunch the numbers, the engineers who build the hardware, and the diplomats who forge alliances. You'll see the challenges, the setbacks, and the breakthroughs, warts and all. Because DART's success is only the beginning. The real story is ours to write, one mission at a time, one calculation at a time, one moment of courage at a time. And I want you right there with me. Thank you for joining me on this cosmic detective story. Until next time, keep looking up, because in the seemingly infinite darkness, our curiosity and determination shine brightest.